In this example, calcium arsenate reacts with lithium sulfide. So what do we have? If we go back and look at our list, do we have an element and an element? Well, calcium arsenate is not just an element, that's a compound. So we have a compound here, and lithium sulfide is another compound. So we have two compound, a compound and a compound. If we look through our list, that's going to give us a double replacement reaction. Compound and compound is a double replacement. So we're going to have a Swarovski. So we start by writing out the formulas properly. Calcium arsenate. Calcium is Ca, has a +2 charge, and arsenate is ASO4. It has a -3 charge, so we need to make those cancel by giving 3 calciums and 2 arsenates. I'm not going to have room to write all this on one line, so I have to do it on 2 lines, I think. We're going to add that to, it's going to react with, that's what the plus means, lithium sulfide. Lithium sulfide, lithium is +1 ion and sulfide is S-2 ion, so we're going to need 2 lithiums and 1 sulfide. Again, we wrote those formulas without worrying about what was on the other side. We just followed the rules for type 1. So now my products are going to be, now this should be all on one line. I've just run out of room, so I have to go down to the next line. We need to, by the way, this was a 3 here. I don't know what happened there. I have to go back and check the tape to see what happened. But anyhow, what we have in a double replacement reaction, we have now a couple of compounds. They're going to switch partners. And when this happens, your positive has to go with the negative. Now, a little trick on these is the outsides are going to go together. It's kind of like the FOIL method. Your outsides are going to end up together, and your insides are going to end up together, because that's, you start with a positive and end with a negative, and so they're going to swap Ruski, and then you have a positive here and a negative here. So calcium, we're going to write a formula for calcium with sulfur, and we don't care about what these say right now. We don't care about that. We're just going to write calcium sulfide's formula using charges. The charge of calcium is +2, the charge of sulfide is -2, so we clearly just need 1 of each. Normally I'd write those above, but it's getting cluttered above, so that's CaS. And our other product, the positive part of this guy is lithium, and the negative part of that guy is arsenate. So lithium is +1, arsenate is ASO4 -3, so we need 3 lithiums and 1 arsenate, and there we go. So that's gotten kind of messy, so let me just kind of rewrite the whole thing in a nice little neat manner. Calcium arsenate. Oops, started writing it out. ASO4 2 plus Li2S arrow CaS plus Li3ASO4. Now I am going to go ahead and balance this with you, just because I want to emphasize that we don't not balance. It's just that we don't worry about balancing while we're writing formulas. We wrote this formula, for example, because the charge of lithium is +1 and the charge of arsenate is -3. So that's why we have 3 lithiums and 1 arsenate. And so we now need to balance. So I see 3 calciums. I'm going to make 3 calciums. I see 2 arsenates. So I'm going to put 2 arsenates. There's no room there, so I have to put it above. You know what I mean? It would go down there. And we got 2 arsenates over here. We've already got 2 arsenates over there. 6 lithiums over here. And we need 6 lithiums over here, so I put a 3 there. And then 3 times sulfur, 3 times sulfur, and we're good. So you worry about making them even when you're balancing. You don't look at it until that point. You only balance at the end. You do not worry about how many lithiums there are, or arsenates there are, while you are writing the formula. It's not till the end, whenever you're doing the balancing, that you worry about that.